So I can only do proper solutions with an equation. In this case, when I'm solving these quadratic equations, I'm just going to do the same process that we did in the previous examples. First thing, I'm going to say, is it equal to 0? The second thing, I'm going to factor it down. And then third thing, I'm going to take all of the factors. If any of the individual factors equal to 0, then I can solve for what x would be in those cases. And then lastly, I'm going to state what my solution is. So for the first one, we can see that it is already equal to 0. So I'm just going to start by factoring this. Now I need to factor this by decomposition because I do have a coefficient of a, and there's no common factors between 10, 13, and -3. So I need two factors that, if I take the coefficient here and the constant, I multiply them together and get -30. I need two factors of -30 that add up to positive 13, and in this case it's going to be -2 and positive 15. I'm going to use that to split up my middle term, and I'm going to say that 10a squared minus 2a plus 15a minus 3 is equal to 0. I'm going to factor by grouping. Group the first two, the second two. The common factor here is 2a, and I'm left with 5a minus 1. In the second set, I can divide both of them by positive 3, and I get 5a minus 1, and I know I've done it correctly because what's in here is the same. Then I'm going to say that it's going to be what's inside the brackets, 5a minus 1, multiplied by what's outside the brackets, 2a plus 3 is equal to 0. I'm going to take the 5a minus 1 is equal to 0, or one of the factors is equal to 0. 5a would equal positive 1, or a would equal positive 1 over 5. In the other case, if 2a plus 3 equals 0, 2a is going to equal -3, or a is going to equal -3 over 2. These are my two possible solutions, which means that a can either equal 1 over 5 or -3 over 2. When I look at b, I don't want to deal with fractions right from the get-go. Because this is an equation and it balances out to 0, I'm going to, in this case, just multiply both sides of the equation by 2. So I'm going to multiply every single term by 2 and say that this would become y squared minus 2y minus 8 is equal to 0 times 2 is still 0. The equation still balances out, and I can still do the same process. Because I have a y squared coefficient of 1, I'm going to do this by inspection. I'm going to say that two numbers that multiply to make -8 but add up to -2 are going to be -4 and positive 2. If y minus 4 equals 0, then y is going to equal positive 4. If y plus 2 equals 0, y is going to equal -2. So I can say that y would either equal 4 or -2 in order to balance out this equation. For example C, well, I don't have everything on one side of the equation, and I can't combine it all in order to factor it down into a single set. So in this case, I'm actually going to need to start by multiplying this out and moving all these terms to the left-hand side of the equation just in order to combine them all together to properly factor this. So I'm going to say that I have 5x squared minus 20x when I multiply this out, and then when I'm moving everything on the right-hand side to the left, I'm going to say it's going to be minus x squared minus 8x and plus 49 are equal to 0. I'm going to combine my like terms. So I got to combine the x squared with the x squared. I got to combine the x with the x. And I'm going to get 4x squared minus 28x plus 49 is equal to 0. I can see that my first term and my last term are both perfect squares. So I'm going to start by saying, well, if I took the square root of this, 2x minus, because it's got a negative middle term, 7 squared is equal to 0, then I can always double check and see if this is correct, because if I take the 2x times negative 7 times 2, it should make my middle term. 2 times negative 7 is negative 14 times 2 is in fact negative 28. So I could just factor this using the perfect square trinomial method. Now, because I have two identical factors, 2x minus 7 and 2x minus 7, then it's going to look like I only have one solution. If I have 2x minus 7 is equal to 0, then 2x is going to equal 7, or x is going to equal 7 over 2. In this case, I have two equivalent roots, which looks like one solution. For example, D. I'm going to move this to the left-hand side and say that I have 3x to the power of 3 minus 27x is equal to 0. I can divide everything by 3, and I'm going to get x to the power of 3 minus 9x is equal to 0. Well, these two have a common factor of x. So x, and I'm left with x squared minus 9 is equal to 0. And because this is a difference of squares inside of here, x and x plus 3, x minus 3 is equal to 0. Well, in this case, I actually have three factors. I have x plus 3, and I have x minus 3. So I have three possible ones I can solve. I could say x equals 0, I could say x plus 3 equals 0, or I could say x minus 3 equals 0. This one already gives me a solution. This one is going to be when x is equal to negative 3, and this one's going to be when x is equal to positive 3. Which means that x can be equal to 0, or positive or negative 3. For examples E and F, these are ones that people really struggle with. This is when the term or the variable is actually a binomial itself. So as opposed to just having x squared and an x and a constant, now I have a binomial squared and then a binomial and then a constant. In order to make my life easier, I always just choose to substitute in a variable that represents this binomial. I typically say a is going to equal 4x minus 1. Why do I want a to equal 4x minus 1? Because then I can rewrite this equation as 12a squared plus 17a minus 5 is equal to 0. This is much easier to factor. At this point, I'm going to take 12 times negative 5 and get negative 60, and I need two factors of negative 60 that add up to 17, and those two factors are going to be negative 3 and positive 20. So I'm going to split up that middle term and continue factoring by decomposition. 12a squared minus 3a plus 20a minus 5 is equal to 0. Factor by grouping, and I get 3a and 4a minus 1 and positive 5 and 4a minus 1 is equal to 0. I have common factor of 4a minus 1, so I'm going to say 4a minus 1 times 3a plus 5 is equal to 0. Now that I have it factored down, I'm going to replace a again with what I said a was up at the top. I said a was 4x minus 1. So I'm going to say that I have 4 and replace a with 4x minus 1 and 3 bracket 4x minus 1 plus 5 are equal to 0. This is going to give me 16x minus 4 minus 1 and 12x minus 3 plus 5 are equal to 0, or 16x minus 5 and 12x plus 2 are equal to 0. At this point, I could split it up and solve it. I could say, well, if 16x minus 5 is equal to 0, then 16x is going to equal 5, or x is going to equal 5 over 16. If 12x plus 2 is equal to 0, 12x is going to equal negative 2, or x is going to equal negative 2 over 12, or negative 1 over 6 if I reduce that fraction. Which means that for the first example, x could either equal 5 over 16 or negative 1 over 6. In the last example, example F, I'm going to say that a is going to equal 2x plus 1. And I'm going to do the same process that I did in the last case. I'm going to say that 9a squared minus 42a plus 49 is equal to 0. I know that this is a perfect square and this is a perfect square, so if I take the square root of 9, I get 3. The square root of 49, I get 7. And 3 times 7 times 2 does give me 42. I can just factor this using my perfect square trinomial method. 3a minus 7 squared is equal to 0. And then I'm going to substitute the value of a back in. 3 bracket 2x plus 1 minus 7 squared is equal to 0, or 6x plus 3 minus 7 squared is equal to 0. 6x minus 4 squared is equal to 0. If 6x minus 4 is equal to 0, then 6x is going to equal 4, or x is going to equal 4 over 6, which would equal 2 over 3. And I can state that x would equal 2 over 3 to make this balance out. Now, it doesn't matter how complex the questions get. Once you get to your final answers, you can always double check the answers that you get by just substituting them back into the equation for x. If you substitute your answer back in for x in all the places that x exist, if you hit enter and it winds up balancing out to 0, then you know you've done it correctly.